Today we're going to look at some contest problems, and I'm going to teach you how to solve them. Here's how the first problem works. A bank vault consists of 4 numbers. Here's the special case. The first 3 numbers in the combination cannot be 9, 1, 2 respectively. If each number has the ability to be from 0 through 9, how many combinations are possible? Okay, so in this, I'm going to teach you 2 ways to do it. Here's the first way. We're going to use complementary counting, and in a way we use it for both, but the concept is mainly complementary counting for this solution. For the other solution, we're just going to use a bit of multiplication in it. So we have let's learn what complementary counting is first. Complementary counting is when we take the total, subtract what we don't need or what we need, and then we get what we need or we don't need. In this case, the total is the number of digits because we're looking for the total combination. We're looking for all the varieties of digits there are. So from 0 through 9, there are 10 digits. 10 digits. From 0 through 9, there are 10 digits for this one, 10 for this one, and 10 for this one. That's a total of 10 power 4 cases. Next, we're going to look at what we don't need. So in this case, we see that 912 cannot be the first. This can be anything it wants to be. So if that seems confusing, let me clear it up. If this was 0 in a case, 9120 was the combination, that would not work. If this was 1, that would not work. If this was 2, that would not work. And if this was any number between 0 through 9, any whole number between 0 through 9, or any irrational number between 0 through 9, it would not work since the first 3 digits stay fixed. So those are the bad cases that do not work. We'll subtract 10 of these cases from 10 power 4. So now this equation is the same as 10,000 subtracted from 10, which is 9,990 possibilities. Now, maybe this does not make sense to you, but let me tell you another way, and maybe that will convince you. And this time, we're not going to use any complementary counting, none of that, but we are going to use some multiplication. Okay, let's keep this complementary counting formula just in case we might need it. Okay. So, let's look at the first 3 digits because that's what this problem mainly focuses on. I lied, we have to use complementary counting as well. So, for the first 3 digits, there is 10 times 10 times 10 possibilities in all. Now this sounds somewhat similar, but don't worry, it's not. There's 10 power 3 possibilities for these digits. Now we know that it can't be 9, 1, or 2. We have to subtract 1 because there is that one case. This number, 912, can never happen, and that is one 3-digit number, and we're accounting for all 3-digit numbers because of the exponent 3. 912 is the only 3-digit number that's not allowed, and that is one case on its own. We subtract 10 power 3 from 1. And that is 1,000 subtracted from 1. And that is 999. But now we have to account for this digit over here. We know that this digit can be anything from 0 through 9. That's 10 numbers. So let's just multiply 999 by 10, and we get our answer of 9,990. Pretty simple. Let's do another problem, and that will be the end of today's video. Let's learn how to do a bit of an easier one now. Let's learn about a difference of squares. 415 squared minus 414 squared. And we're asked to do this in a short amount of time. How do we figure out the answer? Well, let's learn about something really quickly. Let's look at our good variables here, a and b. I'm going to write out this and we're going to FOIL it together and we're going to prove a way to do this. Okay, so a plus b times a minus b. Let's FOIL it out, which means we multiply it. So a times a is a squared. A times negative b is minus b, a. B times a is positive ba. And b times negative b is negative b squared. Now we simplify the equation. Negative b plus ba is nothing but 0. There's no need for that. What we're left with is this whole equation right here simplifies to a squared minus b squared. Now let's look at our problem. 415 squared minus 414 squared. So we've proven how to get a squared minus b squared, which is the same format the problem takes. Let's just plug in our numbers. We know that 415 is a and 414 is b. If we plug it in, we see that 4015, plus 4014 times 4015 minus 4014 equals to 8029 times 1, which is nothing but 8029. We have solved the problem in a short amount of time, and there was no pain in that. Thanks for watching. Like, subscribe, comment on what you want to see next.